Alrighty then, so now we're back in action, folks. So what we were doing is we're measuring the current through each branch, as indicated in figure 6, and we're going to record these in the appropriate space in table 3. So we're going to take the black lead of our meter, put it at this point on branch 1, and put it on our red lead on this point, and I'm measuring 12.54 milliamps. 12.55 milliamps. 12.55 milliamps. Alright, we had calculated 12.33, but we're measuring 12.55. What could be the reason that we have that little difference? Well, even though that says 1 kiloohm, don't forget about resistor tolerance, plus or minus 5% either way. So having a little bit more current than I predicted probably tells me my resistor is a little bit less than the 1 kiloohm resistance that it says is face value. So the next thing I do is measure the current across branch 2, that would be here to here, and I measure 6.23 milliamps. 6.23 milliamps. That'd be 6.23 milliamps for branch number 2. Again, it's a little different, which means resistor tolerance is coming into play. And then finally, branch 3, I measure from here to here, and my meter reads 4.15 milliamps. 4.15 milliamps. 4.15 milliamps current flow. Alright, so again, we calculated 4.11. We're a little higher. Probably just means the resistance is a little lower. So we completed 15. Next thing is 16. Disconnect the black and red wires from the exposed silver and copper colored wires. So we're going to disconnect the black and the red wire from the power line. Disconnect the black and red wires from the circuit board. Take and disconnect the black and red wires from the circuit board, and bring the red and black wire circuit board back to the instructor. Well, since I am the instructor, I ain't bringing it anywhere. Alright, so we're going to turn the page, and there's a couple of questions on the last page. It says in step 8 and 9, 9 and 10, which resistor measured the most voltage across it? So we look back at step 8, 9, and 10, and we're measuring the voltage across the resistors, and it asks us which resistor had the most voltage across it. That would be the voltage for R3. So resistor R3 measures the most voltage across it. How did you calculate the voltage drops across resistors 1, 2, and 3? First of all, I had to calculate total resistance, calculate my total current, and then it was the current times R1, R2, and R3. Alright? So, but individually, right? So it's the current times R1 to get the voltage drop across R1, current times R2 to get the voltage across R2, and then current times R3 to get the voltage across R3. Question number 3. In step 15, which branch measured the least current through it, and why is this? So we're going to go back and look at our currents that we measured. The one that measured the least current was branch 3. So I'm going to say which one. It was branch number 3. And why is this? Well, if I look, branch 3 has the 3K, branch 2 the 2K, 1 the 1K. Branch 3 measures the least amount of current because it has the most amount of resistance. And it's that voltage inversely related with resistance and current. So why is this? Branch 3 had the most resistance. So which branch measured the least current through it? Branch number 3. Why is this? Because branch number 3 had the most resistance. Okay, guys? So that completes our lab. As you go along, remember, if you can't print this lab out, indicate the step numbers and write the values that we came up with. Send it back to me in an email and we'll get your attendance recorded, okay? So little circuit board, we determined that current's the same in series, voltage is divided. Then we turned around and determined that voltage is the same in parallel and that the current is divided. So folks, hope you got something out of this. If you have any questions, feel free to include them in your email. Other than that, folks, stay safe, stay healthy, and hey, have a good time. That's the best we can do at this point. So it's Mr. Randy from the hunker in the bunker to the masses in the classes. I'll see your asses next time.